Welcome to Energy Storage Training video. Energy storage training shows you the nuts and bolts of energy storage, future capability of energy storage, and diverse uses of energy storage in present-day world. TONEX as a pioneer in showing industry for over 15 years with an assortment of customers from government and private segment enterprises is currently declaring the energy storage applications for non-engineers training, which causes you to perceive essentials of energy storage, diverse kinds of energy storage framework, activity standard, difficulties and utilization of energy storage in various ventures. It is determined that energy storage frameworks advertise will reach to 16 billion by 2020. With expanding number of sustainable power source establishments, electric vehicle market, and advances in energy storage showcase in various applications, legitimate training is expected to enhance your insight into energy storage and diverse advances or applications identified with present-day energy storage frameworks in this day and age. TONEX has served the business and the scholarly world with top-notch gatherings, classes, workshops, and solely composed courses in cybersecurity territory, and is satisfied to illuminate proficient colleagues about the ongoing complete training on energy storage applications training for non-engineers. This course covers assortment of points in energy storage training territory, for example, basics of energy storage frameworks, utilization of energy storage in electrical building, use of energy storage in transportation, energy storage in photovoltaic, PV, frameworks, energy storage applications in portable applications, smaller scale control use of energy storage, hydrogen and warm storage, lead corrosive batteries, power device standards, electrochemical storage, and supercapacitors. By taking the energy storage training by TONEX, you will find out about the idea of energy, how to store the energy, kinds of energy putting away gadgets, history of energy storage frameworks, advancement of energy storage by 2050, and long-haul, here and now storage. Find out about the diverse uses of energy storage in electrical frameworks, for example, photovoltaic, PV, hybrid electric vehicle, HEV, controlling voltage and recurrence by energy storage, associating energy storage to a power electronic gadget, controlling charge and release of the battery with control electronic gadget, and energy storage corruption contextual analysis. The energy storage training course by TONEX is intuitive course with a considerable measure of class dialogues and activities, expecting to give you a valuable asset to energy storage applications. You will take in more about use of energy storage in transportation frameworks, for example, street vehicles, rail transportation, substantial vehicles, transports, trains, stream transport and electric autos. Audience. The energy storage training is a 3-day course designed for all professionals in the area of energy storage systems. Non-engineers looking to understand new approaches of storing energy. Individuals who are looking for technical training of energy storage systems. Project managers, quality managers, business managers and directors looking for a comprehensive training in energy storage application and operation. Energy storage producers who look for alternatives to improve their energy storage design and efficiency. Executives and managers who are looking to invest in energy storage area. Investors and contractors who plan to make investments in energy storage industry. Technicians, operators, and maintenance personnel who are or will be working on energy storage projects. Training objectives. Upon completion of the energy storage training course, the attendees are able to understand fundamentals of batteries and concept of storing energy. Understand the materials used in different types of energy storage and to recognize the operation. Recognizes the parameters that control energy storage performance. Describe different application of energy storage in electrical engineering. Explain different application of energy storage in ground, air, or marine transportation systems. Understand the application of energy storage in photovoltaic. Troubleshoot challenges related to energy storage systems. Describe supercapacitors, and their applications in the system. Differentiate thermal and hydrogen storage. Understand the fuel cells and different applications and types of fuel cells in the system. Training outline. Introduction to energy storage systems. Concept of energy. Concept of storing energy. Engineering and non-engineering definition of energy storage. Types of energy storage. Why energy storage? History of energy storage. Rationale for energy storage. Purpose, process and roadmap of energy storage. Key application of energy storage. Current installed capacity. Electricity storage. Thermal storage. Energy storage deployment to 2050. Energy storage development. Short-term storage applications. Long-term storage applications. Policy, finance and international collaborations and more. Energy storage and electrical engineering. Energy storage for the electrical generation units. High-power energy storage. Storage for ancillary services. The special case of intermittent generation. Frequency regulation with energy storage. Active, reactive power control with energy storage. Energy storage applied for transmission systems. Control of investments and congestion management. Frequency regulation and the balancing mechanism. Voltage regulation and power quality. System security and network restoration. Energy storage for distribution networks. Application of energy storage in planning. Application of energy storage for retailers. Sourcing cost reduction with batteries. Application of energy storage for customers. Peak shaving of renewables with energy storage. Energy storage for power flow. Improvement of product quality with energy storage. Reactive power compensation. Energy storage for the balancing. Energy storage and transportation. Electrical energy for transportation. Application of energy storage and ground transportation. Air transportation energy storage. Energy storage and rail transportation. Energy storage and maritime transportation. Energy storage and electric road vehicle. Energy storage in heavy vehicles and buses. Energy storage in two-wheeled vehicles. Guided vehicles, locomotives, underground, tram, trolleybus. Energy storage in river transport, yachts. Hybrid electrical energy and energy storage effect. Parallel architecture. Series architecture. Coupling by road. Hybrid railway vehicle.
Energy storage in photovoltaic systems. Standalone photovoltaic systems. Principles of operation. Energy storage as an indispensable tool. Photovoltaic, PV, market. Sizing storage for autonomous PV systems. Control of PV systems. Maximum power point tracking. Effect of DC/DC conversion. PV hierarchical control. Energy storage selection for PV systems. Lead-acid battery and limited lifetime problem. Battery energy management. Lithium-ion energy storage technology. PV systems in islanded mode. Grid-connected mode and control. Control of islanded mode energy storage. Frequency control. Evolution in electric network. Energy storage for multiple applications. Connection of energy storage to grid, a challenge. Energy storage in mobile applications and micro power sources. Introduction to mobile applications and energy storage. Weak powers. Large powers, a few watts. Energy needs for mobile applications. Battery life, a challenge. Energy storage characteristics in minimum scale. Capacitive storage. Electrochemical storage. Cells. Batteries and accumulators. Fuel cells. Hydrocarbon storage. Power MEMS. Pyroelectricity. Triboelectricity. Radioactive source. Energy storage in small-sized solar application. Thermal energy storage. Chemical. Mechanical energy storage. Hydrogen and thermal storage. Introduction to hydrogen storage. Production of hydrogen. Governmental promotion of the use of hydrogen. Hydrogen storage alternatives. Approaches to hydrogen storage. Pertinent energy parameters. Density and specific density definition. Pressurized storage. Reservoirs. Networks. Cryogenic storage. Mobile storage of liquid hydrogen. Static storage. Solid storage. Physical storage. Chemical storage. Hybrid storage. Economic aspects of hydrogen storage. Sensible heat. Latent heat. Inorganic phase change materials. Organic phase change materials and more. Lead-acid batteries. Basics of PV acid system. Calculation of the MTSE. Variation of cell voltage with state of charge. Potentials of the individual electrodes. Reactions in electrodes. Construction of electrodes. Alloys in electrode grids. Alternative grid materials. Additional design variations. Diffusion of hydrogen. Fuel cells principles. Definition of cell. Chemical energy. Concept of reaction. Proton exchange membrane fuel cells, PEMFs. Solid oxide fuel cell, SOFC. Alkaline fuel cell, AFC. Catalysis. Air supply system and fuel cell. Gas humidification system and fuel cell. General considerations. Possible humidification modes. Fuel cell systems with a reservoir. The static converter at the stack terminals. Lifespan, reliability and diagnosis of fuel cells. Fuel cell faults and origins. Experimental methods for characterization of fuel cells. Diagnostic approaches for fuel cells. Electrochemical storage. Chemical and electrochemical reactions. Major reaction mechanisms in electromechanical cells. Equivalent circuit of electrochemical cells. Generalities of accumulators, principle of operation. Storage to manage electric and transport networks. Evolutions in electrochemical storage. Lithium-ion technology for hybrid electric vehicles, HEV. Lithium-ion technology for solar applications, PV. Lead, NiCd, NiMH. And lithium. HEV and electric vehicle applications. PV applications. Mobile electronics applications. Development of electrode and anode materials. Developments in electrolytes. Processing and recycling of lithium batteries. New batteries. Electrolytes. Printed batteries. Supercapacitors. Introduction to supercapacitors. Double-layer electric capacitor. Electric model of supercapacitors. Thermal model of supercapacitors. Sizing a bank of supercapacitors. Energy criteria for supercapacitors. Power criteria in supercapacitor design. Power interfaces for capacitor. Voltage balance with supercapacitors. Static converters. Applications of supercapacitors. Supercapacitors used as principal sources. Hybrid systems with supercapacitors. Hands-on, workshops and group activities. Labs. Workshops. Group activities. Sample workshops and labs for energy storage training. Energy storage application in photovoltaic systems. Case study on lithium-ion batteries. Lead-acid energy storage case study. Control strategy application for energy storage. Frequency control with energy storage. Power control with energy storage. Charging and discharging case studies. Battery degradation case study. Energy storage capacity and sizing test. Energy storage in series and in parallel case study. Learn more about energy storage training by TONEX. Price, $2,499. Length, 3 days. Visit www.tonex.com. Call TONEX today, 1-972-665-9786.